All right, so today we're going to look at the sine rule again, like yesterday, where we looked at an example of the sine rule. But this time we're going to look at what's called the ambiguous case of the sine rule. And we'll see why it's called the ambiguous case, essentially because it's ambiguous what angle we have in the triangle, because there could actually be two possible angles with an example like this one here. So let's look at this example here. Let's say you get a triangle like this, and you want to calculate this missing angle here. So it's going to be a sine rule problem because you have two sides. You've got a side there, and you've got one of the angles opposite that we need to find. You've got a side here, and we're given this opposite angle there. So it's a sine rule problem. You've got two sides, two angles. It's a sine rule problem. So we're going to need sine of the question mark using our sine rule formula, divided by the opposite side, this 12, is equal to sine of the 20 divided by the opposite side, which is 10. So you can multiply both sides by 12 to get sine question mark equals 12 times by sine 20 divided by 10. We can then do sine inverse of this number that we get to find out what the angle should be. So divide that by 10. Let's do that on the calculator. So 12 times by sine 20, divide that by 10, and then do sine inverse of that answer. So we should get about 24 degrees, or 24.2 degrees to 3 significant figures. Now, if we look at this diagram here, this angle does not look like 24.2 degrees. This looks like an obtuse angle. So obviously this angle we get here is an acute angle. But in the diagram, we see an obtuse angle. It looks kind of like an obtuse angle. So why is that? Well, that's because we can actually draw another 10 centimeter line down here, and then we can create a new triangle like this. And now that triangle there, I mean, again, this is not really an accurate drawing, but we can actually create another 10 centimeter line down here, in addition to this one that we've already got here. And now we've got a new triangle. We've actually got a new triangle with a new angle there, 24.2 degrees. So we've got two possible triangles. We've got a triangle 20 degrees there, 12 centimeters there, and 10 centimeters there. But the 10 centimeters could also be over here to give you an acute angle of 24.2 degrees there. But let's say we did have to find this obtuse angle there. How would you find that out? So you can think about this by thinking about a sine graph. So if we think about a sine graph, so a sketch of what the sine function looks like. So you've got 360 degrees there, you've got 180 degrees there. So sketching y equals sine x, with this being the x-axis there, you've got 90 there, and you've got 270 there. So a sine graph starts at 0, sine 0, 0, then sine 90 is 1, sine of 180 is 0, sine of 270 is -1, and then sine of 360 is 0. So that's what our sine graph looks like. So if we've got an angle of 24 degrees, which is somewhere, let's just say there, 24.2 degrees there, then that means that there's another value that gives us the same y value, that gives us the same sine value, and that's this one here. So to work out this angle here, we have to do 180 take away this one here, because the sine graph has a line of symmetry. So between 0 and 180, there is a line of symmetry at x equals 90 degrees. So if we do 180, so the gap between there, 0 and 24.2, is the same as the gap between there, 180, and this missing angle here. So if we do 180 take away 22.2, so 180 take away 24.2, we'll get the other angle. So 180 take away 24.2, we get 155.8. So this obtuse angle would be 155.8 degrees, but the acute angle would be 24.2 degrees. So this, so with the information we're given, it's ambiguous whether the angle is actually this or the angle is actually that. We don't have enough information to determine which one is the correct one. So this is called the ambiguous case, or an example. So an example of the ambiguous case. So the ambiguous sine rule case, because again, we don't know for certain whether it's going to be the obtuse angle or the acute angle. Ambiguous case of sine rule. So now let's look at like another example. Now let's consider this example. So we've got 12 centimeters there, 13 there. Now we've got obviously an acute angle here. This is some acute angle. Now, does a second triangle exist? Is there going to be a second angle here that exists? So can we draw like a 13 centimeter line to create a new angle, an obtuse angle there? Does this obtuse angle actually exist? So let's use the sine rule. So again, we want to find the angle. So sine of, I'll call it C, so sine of C divided by the opposite side, which is 12, is equal to sine of 50 divided by the opposite side, which is 13. We can multiply both sides by 12, so sine C equals 12 sine 50 divided by 13. We then do sine inverse of that, sine inverse of 12 sine 50 over 13. Put that into the calculator, sine inverse of 12 sin 50 and divide that by 13. So we should get 40, we should get 45 degrees. So 45 degrees, well, 45.0 to 3 significant figures. Let's just do it to 3 significant figures. So that's going to be our angle here. This angle there must be 45.0 degrees. So using our trick to get the obtuse angle, we just do 180 minus 45.0 degrees. So that would give us a 180 take away answer. That would be 135 degrees to 3 significant figures. Now, is this allowed? So obviously angles in a triangle are out to 180. You've got 135 there apparently. Now 135 plus 50, 135 plus 50 gives you 184. So that angle plus this gives you 184. That's bigger than 180. So actually, no, this is not allowed. So yeah, this is not allowed. So actually, in this case, so unlike the triangle before, where we actually could have two possible angles here, so an angle there and an angle there, with this specific triangle, we can't. So we can't have this obtuse angle. There's only one possibility, that this 45 degrees is the only possibility. So I mean, comparing this example here with this example here, what do we notice is different? Well, I mean, we've still got this kind of angle, so like this side angle arrangement. We still got this kind of side to side angle arrangement, because again, we've got like this side angle arrangement on the triangle. But what's different is that this opposite side to the 50 degrees here is 13, and that's bigger to this side adjacent to the 50 degrees. Whereas with this one, the opposite angle to the 20 here was 10, which is smaller than the 12 there. So perhaps something to do with the opposite side being smaller than the adjacent side has something to do with whether we have two possible triangles. Now let's think about this example. If you've got an example like this one, now we've got an obtuse angle down here. So we're given an obtuse angle. Is there going to be a second triangle? Is there going to be a second angle for this to work? Well, if you think about it, no. I mean, we don't really have to do any calculations with this one. We can kind of just see that there's not going to be a second angle. So 13 centimeters, I mean, if we draw a 13 centimeter line down there, obviously it's going to extend below the base of this triangle, which means that this angle would change, and we're not allowed to change this 135. This 135 must stay the same because that's given to us in the question. So we can't change this 13 centimeters. Again, if we move the line, rotate it up like that to 13 centimeters, again, we're going to get a new angle smaller than 135 degrees there, and we're not allowed to change the angle. So yeah, with this example here, where we've got an obtuse angle, still the same arrangements. We got a side, so you've got a side next to a side next to an angle, so it's still this side, this SSA arrangement, but again, we've got this obtuse angle and we've only got one possible triangle. So the answer is no, one possible triangle. So there's only one possible triangle again. So again, how can we determine whether we are going to have two possible cases or an ambiguous case? So this is kind of the rule. So if you are given a side angle of a triangle, so SSA, so like these triangles here, so side angle, side next to a side next to an, so side next to a side next to an angle, side next to a side next to an angle. So not side angle side, not that, where an angle is trapped between two given sides. If you're given two sides of a triangle where a side is next to a side and next to an angle, then there may be two possible triangles. There may be two possible angles for these question marks here opposite one of the given sides in the question. So how can we determine if there are? So if you are given a side in a triangle and you need to find another angle, so let's say you got, again, a side, I'll do this in blue, so side next to a side next to an angle that you're given, and you want to work out one of this angle there, this opposite angle there, and also if this angle A that they give you is acute. So if it's an acute angle, so between 0 and 90 degrees, and if the opposite side to the given angle, so if this length A is a smaller number than the length B, this angle adjacent to the given angle, so opposite to the angle you need, then there are two possible angles for the question mark. So with this specific triangle, we've got a side angle. The side opposite the angle they give you in the question is smaller than the side adjacent to the angle they give you in the question. Then in that case, that means that, yeah, this question mark could be two possible values. It could be this acute angle here, this acute angle, or it could also be an obtuse angle. So it could be this obtuse angle there. So in this specific case, you've got two possibilities, but in all other cases with the sine rule, there's only one angle and one possibility. So this is just a unique case, and this is called the ambiguous case, because again, it's ambiguous whether the angle in the triangle is going to be the acute angle or whether it's going to be the obtuse angle. So that's a summary of how you can determine if the angle that you want to calculate is actually ambiguous and could be two possible values.